Today I will make concentrate hydrogen peroxide. This is the raw material for this experiment. I will distill it with a vacuum pump. At that time, this liquid will boil below 70 degrees. This corresponds to 0.2 atm. I added some hydrogen peroxide to the funnel. Then I opened the valve. Some hydrogen peroxide escaped from the flask because of the vacuum. The video on the right is about the reaction between 30% hydrogen peroxide and potassium permanganate. This is so violently, but I think this is not funny enough. I inject water into the condense. I turn on the switch of the heater, and the thermometer is ready for use. I adjust the amount of air which the vacuum pump extracts to control the boiling point of liquids. Hydrogen peroxide will slightly decompose over 90 degrees centigrade. So I must reduce air pressure. I must control the temperature between 60 and 70 degrees. Low temperature can cause a large amount of mixed vapor to enter the vacuum pump and damage it. So I have better to set up a cooler before the pump. From the page, we can learn that the concentration of hydrogen peroxide can be measured by density method. But these cloudy hydrogen peroxide is contained with some impurities. As far as I'm concerned, there's nothing wrong with these impurities, because these impurities would not lead to the decomposition of hydrogen peroxide. I think this may be a type of stabilizer, as shown in the video. Then I added more liquid to the flask. If you need, you can buy concentrated hydrogen peroxide from Temu China Pinduoduo. Now the temperature is too high, so I increased the pumping rate, but the temperature must higher than 60 degrees, because I don't want to damage the pump. Low temperature means lower pressure. This means more difficult to liquefy vapor, and some vapor will go through the tube and enter the pump. The flask on the left isn't need for zeolite, because of zeolite will catalyzes the decomposition of hydrogen peroxide, and zeolite does not function in vacuum. Otherwise, hydrogen peroxide will decompose into water and oxygen gas. Oxygen can help hydrogen peroxide solution to boil, but if it's water, it will be a different way. Then again, it's best to cover the flask with aluminum foil, because it can prevent hydrogen peroxide from decomposing under light. Light will reduce the yield of this experiment. Otherwise, clean equipment is also important, because some impurities will drive hydrogen peroxide decompose, especially heavy metal ions. When the distillation is nearing completion, I will turn off the heating and I use a vacuum pump to lower the temperature inside the flask. Now I have increased the pumping speed. This way can prevent the decomposition of hydrogen peroxide. Bubbles suddenly appear from the surface of the liquid, because there is no heat provided. This unusual phenomenon is too beautiful. This is the final product. Thanks for watching.